And I want you guys to write this up at the top where it starts, okay? I want you to write, I'm going to try and give you like a flow chart kind of thing to follow so you know what you have to look for, okay? So first of all, there's a couple things that can tell us right off the bat without doing any calculation if there is a triangle or not. So we'd want to look for those things first because they're simpler, okay? So one of those things, so this is what you're going to write at the top, okay? Let's say that they give us this setup. Let's say that this I'm going to call angle A. That means that the side across from it would be called side A, okay? And I'm going to call this one side B, and I'm going to say that's the information they've given us. So they've given us one angle with the side across from it, and then one of the other sides of the triangle. And that makes it an angle side-side situation, right? So this is the danger situation, okay? Now, are they always going to use the letters A and B like we use up here? No. But for me, I'm going to use in our lesson today, angle A is always going to be the one where they gave you the side across from it. So they gave me this side and this angle like paired up. So those are the ones that you're going to compare the way that I'm using A in the notes today. Okay? So the first thing we should know, if angle A is greater than or equal to 90 degrees, okay? This is actually good if you have a big angle in your triangle. What did we talk about? I told you guys it was a good way to check your answers. If angle A is 90 or bigger, what does that mean about angle A in the triangle compared to the other angles of the triangle? It's the largest. You can't have another one that's 90 or bigger, or they would add up to too many degrees, right? So if the angle A is bigger than or equal to 90, that means it's the biggest angle. The biggest angle is supposed to have what across from it? The hypotenuse. If it's a 90, we call it a hypotenuse. But what is this side length compared to the other sides of the triangle? The biggest side, right? It's got to be the biggest. So if they give you a big angle, there's only one thing to check. Either the side across from it is the biggest side they've given you so far. If it's not, the situation doesn't even make sense and you don't even have to do the problem. Okay? So either the side across from it, the little a, has to be the biggest side they've given you, which means it's got to be bigger than side B. That means you can just start triangle and you just go ahead and solve it the way you always have. Okay? But you just pause to think about it for a second. Is the biggest angle not the biggest side? Does that make sense? No, that's not possible. Bigger angles are supposed to have bigger sides across from them. So if they gave you angle A as the biggest angle, but they didn't give you side A as the biggest side, good news and bad news. The bad news is they're lying to you. That's not possible. But the good news is all you have to do and you're done. Okay, because that situation doesn't exist. So if you like not doing work, you'll like it when you're in a situation that the triangle doesn't exist because you don't have to do anything else. Okay? So is this okay for one thing to look at? Okay. So the second thing to look at, okay? If side A is bigger than side B, okay? So whether the angle's the biggest angle or not, if this side is longer than this one over here, will you always be able to connect down and make a triangle? So if they give you this one, and they set this angle so that you can't move it, but this side could be as big or as small as you want. If you know the piece that you're putting in is longer than this piece here, will you for sure be able to connect a triangle? Yes. Okay? And you can't bend it back this way because guess what? It's longer than this one over here. So if you tried to bend it back this way to make a second triangle, it would be too long and would cross over that other line that you were looking at. So if the side that they give you that's across from the angle is the biggest number, you just start. There's just one triangle. Okay. Is this all right with everybody? So the bummer is when you're not in this situation, which means the angle they give you isn't a big angle. It's not 90 degrees or bigger. And this side is not bigger than the other one. At that point, you're unsure. Can it even connect the triangle? Can it make two? And that's where we have to do some more work. Okay? So that's where, this part comes in. Okay? So right above this, the third thing you're going to look at, so if A is not the biggest, right? And angle A is less than 90, then you have to do it. Okay? So you're kind of hoping that the angle side pair they give you has something big in it. You either got the biggest side across from your angle or you've got a big angle, and either you know the big side is across from it. If it's not the big side across from it, you're done because that's not possible, right? When they don't give you something that's bigger than the other stuff so you know that it's supposed to fit and work out, that's when we have to look a little bit deeper. So that's when there are, I keep doing that, sorry, these three situations, okay? So if they give you this information where you still have this angle, you have this side and it's a set length and it has to stop right there, then they give you the third side to put in. Either the third side is too short to make a triangle and there isn't one. The third side is exactly the right size to fit and makes just one triangle. Or the third side is big, but not bigger than the other one they gave you, or else we wouldn't even be doing this, right? We would have just started with one triangle. And it can be kind of angled two different ways, and then we have two triangles. Okay? So how do I know if it's big or not? Okay? Well, this is the smallest distance I would need to connect a triangle, right? That's the easiest way to get from that point back to this line. Right? That's the shortest distance. If I make it at a different angle than 90 degrees, it gets longer. Okay? That means in order for something to complete a triangle here, it has to be at least this long. Okay? I'll call this a height for a minute. What did we do in our little paper when you guys were finding areas of triangles and all this kind of stuff? When I draw an altitude down like this, how did you guys figure out this calculation, this h? Good. Okay? We did this sine of A stuff, right? We used this little right triangle and said, okay, in this little right triangle, and you don't have to write this work yet. So the sine of angle A would equal h over b, which means h would be equal to b times the sine of A. Okay? That's this distance. The perfect distance to make a right triangle here is calculated with this calculation. The other side times the sine of the angle. Okay? So when would you have no triangle? You would have no triangle if the side A that they gave you was too small and couldn't connect this point back down to the other side. Okay? So that means that the side they gave you is smaller than the minimum height requirement. Okay? So the side across from the angle is smaller than this height. But I'm not going to use h because I don't want you guys to have to use an extra calculation. How did I figure out h? This guy right here, right? So this becomes like a key calculation that you're going to do if nothing's big right away and that you know that you can start. You're going to say, okay, I'm going to take the side that's not across from the angle. Okay? And I'm going to multiply it times the sine of the angle, and I'm going to get a number. If the side across from that's smaller than that number, that means it's smaller than the minimum height it would take to complete a triangle, and that's why there's no triangle or no solution. Okay? If I did the calculation, same type of information, okay, and I got that side length A was exactly that distance, there's only one way it could connect the triangle, okay, straight down. So if the side across from the angle is equal to this calculation, when I have just one exact triangle, there's only one way to connect it. Okay? Now, the more complicated case, and probably the case you're all going to be hoping you never get, okay, but you're going to get it sometimes because we're going to practice it, is this case because it's going to require the most work because it doesn't make just one triangle that you have to go and figure out. It makes two different options that we have to go and figure out. Okay? So what's happening in the third case is you have the same type of setup. You have this set angle A, and you have this set side length called B or something else other than A. And then they gave you something that's across from A. But this time, that measurement is bigger than that minimum height requirement calculation. Okay? Now, it's not bigger than this whole side, or else we wouldn't even be here, right? That's a previous decision we would have made. If the side over here was bigger than any other measurements given, we would have known there was one triangle, and we would have just started. But in this case, the side over here was smaller than the other side. So I did this calculation, but it turned out to be bigger than this calculation, which meant either it gets angled in here like this, or it's angled like this. Okay? Which actually means you have these triangles. You have one that looks like this, or you have one that looks like this. Okay, because no one gave you this other side length, so it could be really short like that, or it could be really long like this. And no one gave you this other angle, so it could be really obtuse like this, or it could be acute like this. So are we okay with the analysis part? So now when someone gives you a problem and you want to use law of sines because it's not a right triangle and you just want to figure everything out, if it's any of these types of information, you can just start right away. It doesn't matter. This type of setup requires us to go through the steps that we just looked at. And I'm going to put this screen back up, so if you're not finished writing it, it's fine. But first you say, did they give me a big angle with the side across from it? If they did, that's going to make your analysis easier. If it's the biggest angle, the biggest side should be across from it, I start. If it's not the biggest side, that's conflicting information. It doesn't make sense. Is the side across from the angle the biggest right off the bat? Okay, no matter what size the angle is, then you're good. Start. But if you have that set up and you don't have one of those two situations, then you're going to do this calculation. And remember what this calculation is if they mix up the letters. You're given one angle with the side across from it, and then you're given, like, the other side. Okay? This calculation is the other side times the sine of the angle, and you're comparing it to the side that was given across from the angle to see if it's too small, just right, or too big. Okay? And that's how you're going to make the decisions. Okay, so let's look at some and try. All right, so we're going to look at these. We're going to determine whether they have no, one, or two solutions, and then we're going to look at how to solve them. So solving the ones that have no solution, really easy. You write no solution. Okay? Solving the ones that have one solution, you guys have been doing that, right? You just set up little ratios to try and find what's missing, and you practice solving that kind of equation. The two solution one's going to get a little tricky because we haven't seen how to put that together yet. Okay? All right, so you look at this, okay? They were nice and used the same letters I used. Notice angle A was the angle, and the side across from it is side A, which is 13. Okay? So first thing, is the side across from the angle the biggest side they gave you? No, so you don't get to just start. Okay? Is angle A greater than or equal to 90? No. Okay, so that means we have to do the harder analysis, right? So we're going to compare the side across from the angle. Which side is the side across from the given angle? 13, right? I know because of the letters. So even if they called it C, and my formula said A, I would use what was given as the angle and the side across from it. So 13 is what I want to know. Is 13 big enough to make a triangle? Okay, if it's too small, then the answer is no triangle. If 13 is just right, it makes one triangle. If 13 is a little bit bigger than the calculation, it makes two separate triangles. Okay? So what is the calculation that I'm comparing 13 to? What is that height requirement that I'm trying to compare it to? 16 times the sine of 42. Okay? So this is like a big question mark. How will it turn out? Right? So deep down inside, you're probably hoping it turns out too small because then you don't have to do any work, right? There's no triangle. But if you were trying to build a triangle, you would want it to work out. So if I calculate 16 times the sine of 42, I get 10.7. How does 13 compare to 10.7? Okay, it's larger. So no solution, one solution, or two solutions? Two. Okay, so there are two triangles. So the next thing that's going to help you guys the most once there's two is to kind of understand the setup. And I like to draw it the way that I showed you guys in the notes every time, okay? It just helps me be less confused. So I like to set like this is the angle they set right here. Okay? So that's like my angle A. This is whatever the other side is, not across from angle A, but the other side. So in this case would be B, right? And then the thing across from it would be over there. So for me, this is 42 degrees. This is the side not across from the angle, so it's 16. And then this is the tricky part, okay? But if I always draw it like this, I can draw this as long as I want, right? There's no requirement on that. So the side across from the 42-degree angle is supposed to be 13, and I just figured out there's two triangles. So that means somebody can connect the 13 from here to here like this, or they can connect it from here to here like this. So again, I like this angle, and then the stationary side is up here, and I just draw this really long line here so that I can set up my two triangles. Okay. Over here, I'm going to separate them so that as I solve them, I don't get confused with which one's which. Okay. This is a big deal when you guys do this, just because there's a lot of work because there's two of them, and you don't want to miss it because you mixed up the stuff. If you do all this work, you want to get the problem right? If you're doing all this stuff. So over here, I'm going to split up my two options. Okay. So is everybody okay with the fact that one triangle is this right here? Okay? So one triangle looks like this. Okay? So this is angle A, this is the 16, this is the 13, this is 42 degrees. And since they're calling that side B, that would make this angle B, and then you can call the other one whatever you want. I just like to work with A's, B's, and C's. Yes?
So the missing side should be the same for both triangles? Or
no? So for this triangle, it's going to be smaller, and then for this one, it's going to be longer. Yeah. Because in this triangle, this angle is going to be obtuse, and 16 is going to be the biggest side that's across from it. It's going to make this angle really small, and this is the smallest side. But when we extend it out here, this angle's not going to be obtuse, which means 16 might not be the biggest side. This one might be bigger with this side across from it. Okay? So the second triangle looks like this. So here's my 42 degrees, here's my 13, and here's my 16. And then I'll put in the appropriate labels so I just keep track of everything. Is everybody okay with this so far? So basically, it sucks when you get angle side because you have to pause the whole world and go through this analysis in your head about what you really have. And then this is kind of like the worst of the situations as far as the amount of work you're going to have to do. If there's two triangles, you have double the work essentially, right? Okay? So, when we go to solve the triangle, okay, notice that at first you can't tell a difference. Let's say I'm going to use the law of sines. Can somebody give me one of the ratios, one of the sine of what over what can I use with these triangles? What's one ratio? Yeah, so you guys get what Lila's saying? She's saying 42 is across from 13. So one of the ratios we can set up is the sine of 42 over 13. And then somebody different, tell me what I could set that equal to. Mikey. Good. Is it okay if I use the letter B so I can keep track of which one's which? Okay. So sine of B over 16. We're kind of forced to make that choice at this point, right? We can't figure out any more angles because we can't add them up to 180. We don't know what the other side is. This is the only problem that we can set up. The funny thing is, what is this going to find for us? We go through and we solve, what are we going to find? Angle B. Is angle B the same size in each of these triangles? No. So, though this is the only equation you could set up for both of them, the way that the inverse sine calculation works, it's either going to just find you the obtuse angle or it's just going to find you the acute angle. We'll see in our calculator when we get there, and then I'll show you how you can take that information and transfer it over to the other. Okay. So we would this by 16. Okay. Have sine of B equals this fraction itself. So my step before this says the sine of B is equal to this calculation, and I know I can put this calculation in the calculator, okay? And when I do so, I'm going to get some decimal. But how then do I get B by itself without the word sine in front of it? The inverse sine, okay? So I'm going to have to do the inverse sine of whatever that decimal turned out to be. is 0.8235. The 0.8235, I put 16 times the sine of 42 and then divided by the 13. And then I'm going to do inverse sine of that on the calculator. And so it gives me 55.4 degrees for angle B. So that is not the measure of angle B in each of the triangles, because one is clearly an obtuse, the way we angled the side, and one is an acute. Is this acute or obtuse? Acute. So it is the measurement of the angle B in this triangle. So how would I then go find angle C in that triangle? Add them up and subtract them from 180. So I'll go ahead and do that. And so that gives me 82. And then how would I find side length C in that triangle? I'm so close to being done with it. So can I do a squared plus b squared equals c squared? No. Okay, because I don't have 90-degree angle. But what can I do? What did we do? What have we been doing in the stuff we've been practicing? Yeah, our ratios, our law of sines, right? So I can set up the same thing, sine of 42 over 13 again. So sine of 42 over 13. But I'm going to set it equal to sine of 82.6 over little side c. Okay? So then I will cross multiply. And then divide by the sine of 32. And then that will give me side length C. Okay, so I get 24.3. Does my triangle make sense? Are larger angles across from larger sides? Okay?
Why did you put sine of 32? 42.
Oh, it's 42. Thanks, Ben. Sorry, because I wrote it down wrong. So it's probably not quite this. So let's see. 13. Thank you, Ben. By sine of 42. So it should be 19.3. Sorry. Yes, Ken.
So we're gonna have to be able to recognize like what triangle has like the obtuse angle and which one has the acute.
Yeah, so the one that you angle this way, though, is always going to have this acute angle here, and that's always going to be what it's found. So we seem stuck with the other triangle, though, right? Like, we can't set up this equation. We already know how it works out. So how do I solve this one? So there's actually a cool geometry. I know I think it's cool, and you guys probably won't think it's as cool. But if I go back to the original drawing where I put these two 13-length sides in here, do you guys remember if they're, so this is not one of the triangles we're solving, but in this picture, it's like a little mini isosceles triangle, right? Do you guys remember if two sides are equal of a triangle, what that means about the two angles? They're equal, right? And you guys figured this one out right over here, right? It was 55.4. So if this one is 55.4, then this one is 55.4, which I don't really care. But I do care about this one right here. That's the one I need right there, and it's right next to it. So now I have this picture where this one's 55.4, and I really want this one right next to it. What's the relationship between those two angles? We subtract 180. So every time that I find this acute angle, how can I find this obtuse angle? Subtract it from 180. Okay? So I'm going to do, because the picture always looks the same, right? Even when the numbers change, if you're in this situation. So they're always going to have this relationship that they add up to 180. So once I find that small angle B, in the other triangle, the angle B that is obtuse is always going to be 180 different from that. Okay? So I'm going to do 180 minus that 55.4, and that's going to give me 124.6. Okay? repeat some of the work. This is why the 2 triangle one is long, right? We should have known it's going to be long. We're solving for 2 triangles. So I'm going to add these 2 up and subtract from 180 to get the other angle up there. So 124.6 plus 42, and then subtract it from 180. Gives me 13.4. And then the only thing I'm missing in that triangle is its side length, C. So how am I going to go about solving for that? What's that? I just need this. The worksheet that you guys did last night for homework and the night before, if I gave you this picture and said, find side length AB, how would you find it? Yeah. Right? Just set up some sine ratios. If you know, once you know the triangle exists, if you have one angle and one side across from it, and you have one piece of something else, you can find all the missing stuff using the law of sines. Okay? So we're going to set up sine of 42 over 13 and set it equal to sine of 13.4 over c. Okay? And then we would cross multiply. Just the solving is going to look the exact same as this, just with slightly different numbers, right? We're going to have c times the sine of 42. I won't write it incorrectly this time. 13 times the sine of 13.4 divided by the sine of 42, and you'll have side length c is. So 13 times the sine of 13.4. So this is going to be 4.5. Right? And do those measurements generally make sense for that triangle? Okay, so we have smaller angles across from smaller sides, whatever. Okay, so the hardest part for students tends to be what we did at the beginning. It's not that this part's not hard. Please, if you're struggling with this, I'm not saying it's easy. Okay, that's not. This is not easy. But once you've had enough practice with the law of sines, if you keep solving those triangles, you guys get better and better at the setup and the solving. So what tends to become the most difficult part is first deciding if there are 2 triangles or not. And then once you have 2, it's really hard for people to get the right setup. So again, I tell you guys, I like to always, whatever angle they give me, I like to put that one right here in this corner. Whatever side length they give me that's not across from that, I like to put it up here. That gives me freedom to make this other side as long or as short as I want, so I can always put the 2 sides in there visually how I can see them. It gets a little confusing if you start mixing up the way that you've set it up. Okay, Lila? Yeah, so we're only doing the analysis in this. If they give you 2 angles and the side across from one of them, you're good to just go start. This angle matched with that side equals the sine of this angle over the missing side. All of these other methods, well, not the angle. You won't get one like that because it would be unsolvable because you have no sides yet. But all of these other situations, you just get to dive right in and start because of the geometry principles. They for sure have one and only one way of building the triangle. It's this one that creates the craziness. Okay? So we only do this special analysis in that situation. And that's why that postulate didn't work when you were in geometry to prove 2 triangles congruent. Because you can see, I can have the same angle side that you have, and we could have 2 different triangles so they don't have to be the same size. Okay? All right, so you guys try this one. Okay, so first look at the setup, right? Did they give you the angle side setup? Do you have the angle, the side across from it, and one of the other sides? Yes. Okay, so that means you need to do the analysis. So with your groups real quick, do the analysis and just make a decision. First of all, I know I have to do this because I have angle, the side across from it, and another side. That means I'm in the angle side situation. Okay? So this is the sucky situation. I don't get to just start. I have to stop and think. So the first thing I hope for is the angle really big or is the side across from it the biggest side? Because right away that will decide for me one triangle or no triangles. But that's not the case, right? The angle's not 90 or above and the side across from it's not bigger. So I can't make the quick decision. So then remember what I'm doing. I'm comparing the side across from the given angle, which is 2, to the other side times the sine of the angle. Okay? So what did 10 times the sine of 50 turn out to be? Mikey? 7.6. So how does 2 compare to 7.6? Less than. So what does that mean? It's too short to complete the triangle. This was what I would need if I drew the altitude straight down like you guys did on those area problems and calculated it. It would be 7.6. Which means if this side length is only 2, 2's not going to be enough to go straight down and connect, which means what? No triangle or no solution. Okay. You want your test to have all of these on it? Okay. All right. Okay, so situation C. Is it an angle side-side situation? Are you given the angle, the side across from it, and the other side? No, because the angle we're given is called A, which means the side across from it would be called little a. And they didn't give us that, which means it's not the angle side-side situation. So that seems good, right? Okay. So then you can just draw yourself a little sketch. If I'm not in the angle side-side situation, then the triangle exists. The question is, what does it look like? Can I solve it? Stuff like that. Call myself a generic ABC triangle. Okay. And angle A is 67. Side B is 35. Side C is 47. So how would I try to go about solving this triangle? Mikey. Good. So what were you thinking, Mikey? What were you trying to do?
I was trying to do 67, sine 67 over, but there's no.
Yeah. So like.
There's no number.
Good. So this is good in the sense that we don't have to do all the stuff we just had to do in the last problems, right? No analysis because it's not the angle side-side. But does the law of sines help you in this situation? No. So you have a couple of options. Option 1, what could you do? Maggie? Okay, you could find the area with this given information. Okay, that won't help you find the missing pieces though. No, but if you think about how you found the area on that handout that we did, the way you dropped down the altitude, that could help you find the missing pieces. So if you dropped an altitude down here, had a 90-degree angle, and figured out this, right? You could figure out how the 35 splits up. You could figure out this, and then you'd have two sides over here to help you figure out the other stuff in the triangle over there. Right now, that would be our only option, okay? But on Friday, we're going to learn the law of cosines, okay? And the law of cosines is going to give you another law. But again, remember, the law of sines and the law of cosines, could you still solve stuff without them? Did you guys do it prior to us doing this? Yes. Okay, so if you're stuck on the test and you forget one of the formulas and one of the laws, you start drawing in altitudes and you start doing trig on little right triangles till you find everything that you need, right? The purpose of these laws is to make it faster, but if you don't remember the law, it doesn't make it faster, then just depend on the old way that you used to do it. Okay? So, but the laws are just there to make it quicker. So what you guys are going to do tomorrow is you guys are going to do homework 3, which is the remainder of the handout that you already have. I'm not going to be here tomorrow. Okay? I have a meeting at the